Okay, welcome to Lesson 12. Let's think about the unit circle here for a minute. The unit circle has what we've been learning or what we've been practicing in our homework lessons is that no matter what point I'm at on the unit circle, the hypotenuse is 1, the x value is the cosine, the y value is the sine. All right, so looking at this unit circle, what do we see? Let me change colors here. What do we see about the tangent of an angle? Well, we know the tangent is the opposite over the hypotenuse, so the tangent is sine of theta over cosine theta. Sine of theta over cosine theta. Well, using the same unit circle and Pythagorean theorem, we can see sine squared plus cosine squared equals 1 squared. So sine squared plus cosine squared is 1. Both of these trig identities come straight from the idea that on the unit circle, the x value is the cosine, the y value is the sine. All right, what about when I add two angles together? The sine of a plus b. Well, we did this quite a bit last year, so I'm just going to remind you of the formula. The sine of a plus b is sine A cosine B plus cosine A sine B. Cosine A sine B. Whoops, B. Cosine A sine B. All right, so sine of A plus B is sine A cosine B plus cosine A sine B. All right, cosine of A plus B is cosine A cosine B. What do we remember about the cosine? The cosine gets the negative. You're going to hear that a lot this year. The cosine gets the negative. Cosine of A plus B is cosine A cosine B minus sine A sine B. All right, so the sine of A plus B is sine A cosine B cosine A sine B, whereas cosine of A plus B is cosine A cosine B minus sine A sine B. Well, sine of A minus B, the only thing that changes here is that this becomes minus. So the sine of A minus B is sine A cosine B minus cosine A sine B. And then in the same way, cosine of A minus B, it changes sign. Becomes cosine A cosine B plus sine A sine B. All right. One of the ways that it's easier to remember this is actually from the double angle formulas. So let's talk about the double angles. What if A and B are the same angle? All right, so what if A and B are the same angle? So what if it's sine of A plus A? Well, if it were sine of A plus A, that would be sine A cosine A again plus cosine A sine A again, where these are just the same term. So this becomes 2 times the sine of A cosine A. All right, so 2 times sine A cosine A of the sine of 2A. Well, the cosine of A plus A, the cosine of A plus A becomes cosine of the first one, cosine of the second one, but that's the same angle. Remember, the cosine gets the negative, minus sine of the first one, sine of the second one, but that's the same angle. So the cosine of 2A becomes cosine squared A minus sine squared A. This identity we use a lot. This one we use often. This one we use a lot. So these are important to remember. And honestly, remembering the double angle helps me remember the A plus B. All right, let's do a quick example problem or two. Let's see here. All right, so the sine of theta plus pi over 4. The sine of theta plus pi over 4. Well, that's an A plus B. So that would be sine A cosine B plus cosine A sine B, but A is theta, so this is just sine theta plus cosine theta. And B is pi over 4. Very quickly, replace pi with 180 and you get 45 degrees. So cosine 45 plus cosine sine 45. Well, cosine of 45 and the sine of 45, we know that those are both 1 over square root of 2. And so this becomes the sine of theta times square root of 2 over 2 plus cosine theta times square root of 2 over 2. Factor that out. Parenthesis sine theta plus cosine theta. All right, so very quickly, shifting a sine wave 45 degrees to the left, remember subtract the shift, shifting a sine wave 45 degrees to the left is the same as taking square root of 2 over 2 sine theta plus cosine theta. All right, so that's sine of A plus B. Now we're asked to find the cosine of 15 degrees, given that 15 is 60 minus 45. So what we're really asked to find is the cosine of 60 minus 45. Well, cosine of A minus B is going to be cosine A, cosine B, plus, remember that cosine gets the opposite sign, sine A, sine B. Well, A is 60 degrees, so this becomes cosine 60, B is 45, cosine 45. Notice it's not negative 45, it's 45. The negative sign is taken care of right there. The minus 45 is taken care of right there. Plus sine 60, sine 45, and very quickly, 60 degrees is right here, square root of 3, 2, 1. So the cosine of 60 is 1/2. The sine of 60 is square root of 3 over 2. And from up above, we know the cosine of 45 is square root of 2 over 2. The sine of 45 is square root of 2 over 2. So this becomes square root of 2 over 4 plus square root of 6 over 4. So we'll probably find a common denominator. Square root of 2 plus square root of 6 all over 4. Square root of 2 plus square root of 6 all over 4. All right, so that's using a couple of our trig identities. All right, finally, something new, a new idea here. All right, the new idea here is that the slope, remember M, the slope of a line is equal to the tangent of the angle the line forms with the x-axis. So this 60-degree angle right here, so whether this line is here or I could shift it over here, right? Whatever angle it forms with the x-axis, the slope is the tangent of 60 degrees. The tangent of 60 degrees is square root of 3 over 1, right, or square root of 3. 135 degrees, this angle right here, you could think of it as 135 degrees, or you could think of it as 45 degrees, whether the line is here or whether it's shifted over here. Either way, 135 or negative 45, both of those have the slope of -1, have a tangent of -1. So the tangent of 60 is square root of 3, that's the slope of this line. The tangent of 135 is -1, that's the slope of this line. Or you could say the tangent of -45 is also -1. All right, so this brings us to a fairly new idea. This idea that the tangent is the slope of a line is equal to the tangent of the angle. This leads to how to find the angle of intersection. So if I've got line 1 here and line 2 here, the tangent of the angle that these two lines intersect at, the tangent, there it is, that these two lines intersect at is equal to slope 1 minus the slope of line 2 divided by 1 plus slope 1, slope 2. Where in the world did that come from, and how am I ever going to remember that? Well, it's actually pretty straightforward. So let's show you where that comes from. All right, so here's my two lines, right? Slope 1, the slope of this line right here, if I draw a horizontal line, not very horizontal, but if I draw a horizontal line here, the slope of this red line is the tangent of angle A. And the slope of this green line is the tangent of angle B. Well, we know that from, vertical angles, this angle here is equivalent to that angle, right, the angle of intersection. And these three angles, B plus phi plus this angle, have to add to 180 degrees. Well, this angle is the supplement of A, so that's 180 minus A. So B plus phi plus 180 minus A equals 180. Rearrange that equation and I'll get phi is equal to B minus A. So the angle of intersection is equal to this angle minus this angle. Well, what's that got? How's that come up with the tangent formula? Well, if the angles are equal, then the tangents are equal. So this means the tangent of phi is equal to the tangent of B minus A. Okay, what's that got to do with slope? Let's think about it. What is tangent? That's sine of B minus A divided by, excuse me, that's supposed to be A minus B, isn't it? Back this up. Rearranging this equation correctly, this becomes B minus A minus B, excuse me. This becomes A minus B pen. A minus B. Eraser. A minus B. Let me fix that. Yep. Minus B. You can do the trig, not the algebra. All right, A minus B. The sine of A minus B divided by the cosine of A minus B. Well, sine, remember, is sine A cosine B minus cosine A sine B divided by cosine is going to be cosine A cosine B plus, the cosine gets the opposite term, plus sine A sine B. We might or might not remember from last year, if I take every single one of these terms and I divide this term, this term, this term, and this term by cosine A cosine B. Cosine A cosine B cosine A cosine B cosine A cosine B. What happens? Cosine B cancels here, leaving me with sine A over cosine A, which we know is tangent A. Cosine A cancels here, leaving me with sine A over cosine B, which is tangent B, divided by 1, right? This cancels, divided by 1 minus tangent A, tangent B. Well, what do we know about the slope? The slope is equal to the tangent, whoops, I'll bring it up here. So the tangent of the angle of intersection is equal to the slope of line 1 minus the slope of line 2 divided by 1 plus, that should be a plus, plus slope 1 times slope 2. Okay, so that's something new for you. That's something new for you. And it's a simple proof. It's in your textbook, but they kind of leave this part out and it takes you a little while to figure out what they're doing. Okay, last subject. Whew. And then I'm going to have to break this into 2 videos. Last subject are half angles. Half angle identities. Half angle identities show up often in trig and show up often in calculus, and they're just supposed to be something that we've developed often enough that we know how to do them. They both come from the idea of the cosine of 2a is cosine squared minus sine squared. Well, if we take the idea that sine squared plus cosine squared equals 1, then instead of cosine squared, I'm going to put 1 minus sine squared. So the cosine of 2a is equal to 1 minus sine squared a minus sine squared a, or it's equal to 1 minus 2 sine squared a is the cosine of 2a. Alright, solving for sine squared of a, I will get 2, let me bring it to this side, sine squared a equals 1 minus the cosine of 2a. So sine squared a is equal to 1/2 minus 1/2 the cosine of twice the angle. Well, if I come in here and I let a equal x over 2, then the sine squared of x over 2 is 1/2 minus 1/2 x over 2, 2 times x over 2 cosine of x. So finally, I think I'm going to run out of space here. Sine of x over 2, the sine of the half angle, is equal to plus or minus the square root of 1/2 minus 1/2 cosine x. And you can develop the cosine of the half angle in a very similar way, and you'll get the cosine of x over 2 is plus or minus the square root of, I have to find my half angle identities. Yeah. I'm supposed to know these. Cosine of x over 2 is plus or minus 1/2 plus 1/2 cosine of x. All right, these half angle identities are in your textbook. Use them, develop them until you know them. That's about the only way you're going to learn them. All right, I'll do the second half of the lesson in a separate video.